Hi everyone, Mr. Wilson here. We're still in our linear inequality packet, and we're going to be going over examples 3, 4, and 5. So this is kind of our middle section here, that third learning objective. So example 3 here, we're just graphing linear equations. So linear equations are just lines. So y equals something with x, we have a y, and we have an x. So these two in class we're going to be doing as a do now. So I'm going to have you, if you weren't in class, that's fine. Go ahead and pause the video. I want you to try these two questions on your own. I'm going to put up the answers here in a second. All right, so hopefully you've had a chance to pause the video and try these. Here are the answers, and I'm just going to kind of talk through them because this should be review. So y equals mx plus b is the format of this, and really what we want when we're graphing lines. The number in front of x, m, is our slope, and the number being added at the end is our y-intercept. So the y-intercept is where we start. We start with a value at 2 on my y-axis. There's my y-axis. Then we use our slope to make some points connect our lines. So we started our y-intercept. Our slope is 2, so we go up 2 over 1, up 2 over 1. And then we do the same thing opposite. Down 2, left 1, down 2, left 1. And we see this is kind of how we get the points. I used my ruler, made a nice line. For number 2, though, there's a little bit more work involved because we're not in this nice y equals mx plus b format. So we have to solve for y here. So the first thing I did is I subtracted 12 on both sides. And when I did that, the 12's canceled. I got a negative 12 on the right-hand side. So I wrote in the 1 here for the division that I'm about to do. So x minus 12 is what I get on the right-hand side. Then I divide by negative 4 because that's the number in front of y, and we want y by itself, right? We're trying to solve for y. So when we divide by negative 4, it cancels out here. We have 1 over negative 4 with an x, so negative 1/4 x, minus minus 12 all over negative 4. So negative over negative becomes positive, and 4 goes into 12 3 times. So this is how I got the equation for this line. And I go ahead and graph that by putting my y-intercept at 3. That's this guy, so that's my b value. And the slope is going to be my negative 1 over 4. So starting at my y-intercept at 3, we go down 1, right 4. 1, 2, 3, 4. Or we can go up 1, left 4. 1, 2, 3, 4. So I have 1, 2, 3 points. I used my ruler, connected those in a line, and that is how I got that line. So I'm not going to be going into any more detail on that, but I wanted you guys to at least see that. Let's take a look at example 4. This is really the new stuff. Well, before we get into number 4, let's talk about the steps for graphing these linear inequalities. So linear inequalities, that's what we've been dealing with so far. It's stuff that looks like this, where we have an x and a y and an inequality symbol as opposed to an equal sign. So our first step in our steps is we're going to change our inequality into slope intercept form, which we should remember to be this guy. That is slope intercept form, y equals mx plus b. So once we get it into that format, we need to kind of do some thinking. We're going to graph the equation we find in this form, but we have to recognize if we have a less than or greater than symbol versus a less than or equal to or a greater than or equal to. So the key here is that here we have our equal to, here we don't. So if we don't have equal to, our line is going to be dashed. And this represents the fact that we're not equal to on that line. Whereas over here, when we have the equal to part, we're going to be a solid line. And that is because we're equal to on that line. So that's the next big thing. And then what we're going to do is we're going to shade a side of this line. And in order to do that, we're going to test a point. So we're going to test any point not on a line. And we'll talk about this here in a second. It'll make more sense with the example. If the point satisfies our inequality, we shade the side with the point. So if we test, say, 0, 0, and our line is something like this, 0, 0 is here, it's going to mean we're going to be shading on this side. If it was false, then we would shade on the opposite side. So if the point does not satisfy, the inequality, then we shade the opposite side of the plane. That's the idea I just talked about. So let's take a look at example 4. And I think the steps will make more sense when we do an example here. So our first step is we need to change it into slope-intercept form. This is definitely not in slope-intercept form. It doesn't look anything like y equals mx plus b. And we're going to kind of ignore this equal sign, and we're going to think about it. This is our equal sign. So we want to solve for y. So first thing, let's subtract 3x. We want to get that 3x to the other side. Cancels out over here. We're going to get 2y is greater than negative 3x plus 6. Well, we still need to get the y by itself, so we're going to get rid of that 2. So we're going to divide by 2, divide by 2, divide by 2. The 2's cancel out on the left. We're going to get y is greater than negative 3 over 2x, right? Negative 3 over 2x. And then 6 divided by 2 is 3. So this is my inequality. And that was my first step. Our second step, we need to think about whether or not we're a dashed or a solid line. Well, since we're greater than up here, we're going to be using a dashed line. So here, I'm just going to make a note, we're going to be making a dashed line. So we need to grab the equation we found in step 1 and then be making it a dashed line. So let's go ahead and do that. So the 3 values, my y-intercept. So my b is equal to 3, and my m is equal to, my slope is negative 3 over 2. So I'm going to put my b here at 3. My slope is negative 3 over 2. So I'm going to go down 3, 1, 2, 3, right 2. Same thing again. Down 3, right 2. And we can do the same thing one more time. Down 3, right 2. And let's do the same thing going the opposite way. So we're going to go up 3, left 2. We have some really nice points there. And what you want to do is you want to connect those in a line that is dashed. So the way I do that is I'm going to use my ruler. And then instead of just drawing the line, I'm going to make it a nice dashed line here. All right. So you kind of get the idea. There's our dashed line. We're going through all of those points. And yeah, so we took care of step 2. But because this is inequality, we're either going to be on this kind of upper side of the inequality or down here. We're going to be shading one side or the other. So we need to test any point not on the line. If the point satisfies the inequality, we shade the side with that point. If the point does not satisfy the inequality, then we shade the opposite. So we're going to test 0, 0. And I'm going to encourage you guys always test 0, 0 because it almost always works out nicely. You can always use 0, 0 unless your line goes through the origin. So we plug in 0, 0 into our original equation. We're going to get 3 times 0 plus 2 times 0 is greater than or equal to 6. So 3 times 0 is 0, 2 times 0 is 0, so 0 plus 0 is greater than or equal to 6. So 0 is greater than 6. Well, that's a false statement. And as you remember from our first section, because we get a false statement, 0, 0 does not satisfy this inequality. So 0, 0 is over here, but we don't shade 0, 0. Don't shade the 0, 0 side. I'm going to put side in quotation just because I'm thinking about it as either this side of the line or that side of the line. Those are our two options. 0, 0 is on this down or left, so we're going to be shading the opposite, so up here. So we're going to shade everything on this side. And what it means for us to be shading on this side of our line is that if we pick any point in this shaded region, it will satisfy this inequality, which is really nice. You might remember that as well from our first section. So that's kind of the overview of how we graph these. And I want to walk through example 5 very quickly, but they're a little bit different in that they don't really look like slope-intercept form, right? We're thinking about that as y equals mx plus b. These graphs, when we have just one variable, they're going to be either vertical or horizontal. So our vertical lines are when we have x, our horizontal lines are when we're going to have y. So this first one here, this is a vertical line at -3. So our greater than doesn't have an equal to part, so we have a dashed line at -3. Well, -3 on our x-axis is right here. So we're going to have a vertical line right there. So I'm going to use my ruler. That's how my vertical line is